Hi everyone! In this video, we will calculate and interpret the confidence interval for a population mean with an unknown standard deviation. The blood pressure readings of a patient in a hospital are normally distributed with a population standard deviation of 12 millimeters of mercury and an unknown population mean. A random sample of 20 patients is taken and results in a sample mean of 120 millimeters of mercury. What is the correct interpretation of the 95% confidence interval? Let's go ahead and gather all the data that we were given in the problem. We know that it's normally distributed, which means we can use our normal distribution tools. And the next part is that the population standard deviation is given to us of 12 millimeters of mercury. The population standard deviation is represented with sigma. So let's go ahead and notate that sigma is 12. We also know that we have an unknown population mean. The population mean is represented with mu, and this is not known. So we're going to need something to replace that or estimate the mu, and we'll get there in just a minute. The next part is that we have a sample of 20 patients. The 20 patients is the number of the sample size. That means n is 20. And the last thing is that this the sample of 20 patients results in a sample mean of 120 millimeters of mercury. A sample mean is represented with x bar, and this is a mean of 120. And we can use it to estimate our unknown population mean. So instead of using this, we're going to use the 120. Let's go ahead and use our calculator to calculate the confidence interval. To do that, we will go to Stat and over to Tests. There are two intervals, the z-interval and the t-interval. We're going to use the z-interval because we have the known population standard deviation. If we didn't have the population standard deviation, if it was unknown, then we would use the t-interval. We can go ahead and arrow down, or we could just press 7 and enter. Either way will get us to the z-interval. And we have statistics that we're going to be entering in, not data in a list. And we have the standard deviation of 12 that was given to us, the sample mean of 120, and the sample size of 20. And so we'll put in 20. And the confidence level, it's already there, is 95%. So we can go to calculate this for us. And we have a confidence interval of 100. Let's go ahead and round this to the nearest whole number. So we're going to go from 115 to 125 for our confidence interval. Now let's go ahead and interpret our confidence interval. If we go back to our original question, we know that we have the population standard deviation, but we have an unknown population mean. In fact, we used the sample mean as an estimate for our population mean. And since the sample mean is not the population mean, it gives us a range that would be for our population mean. It may or it may not fall within that range, but we are 95% confident that it will be in this range. So we are 95% confident that the true population mean will fall between 115 and 125 millimeters of mercury for the blood pressure readings at for the patients in this hospital. And now we're all done.